Hi everyone, we're going to prove triangles congruent by side angle side and hypotenuse leg congruence theorems. And it's more of an informational video versus actual problems. So basically your vocabulary is you need to know in a right triangle you have two legs. So these are the two legs. This is your right angle right here. This is 90 degrees. So a side adjacent to the right angle is called a leg. So this is a leg and this is a leg. Okay? And the side opposite the right angle is called the hypotenuse. So a right triangle has two legs. They don't have to be equal, but they have two legs and hypotenuse. All right. So based off our postulate 20, side angle side, if two sides of the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So when you're looking at triangles, let's just make some generic triangle. If you have, this is a side angle side. So if I draw another similar generic triangle, if these two sides are congruent and our angle is congruent and the side is congruent, then the triangles are congruent, even though we're not dealing with this side at all. We're not dealing with that. Just side angle side. All right? So we're going to look at an example with a proof. We're going to prove that triangle JKN is congruent to LMN. So LMN. So what we want is a side angle side postulate. So what we want is these two angles to be congruent. And they are congruent by the vertical angles theorem. Then it follows that since we have a side, these sides are congruent. So we have side angle side, that they match up for both triangles. That means both triangles are congruent. All right. What can you conclude about ABC and CDA triangle? So basically, we know the opposite sides of the rectangle are congruent because this is 90 degrees and 90 degrees. And we know that it's a rectangle, so we know that all of these are 90 degrees. I don't know if that matters. All right. So we know that opposite sides of the rectangle are congruent. Therefore, we have a side. These are always on a rectangle congruent. These two sides are congruent. So what we have is a side angle side, or you can do side angle side. So by the side angle side congruence postulate, the triangles are congruent. All right. Now here's our hypotenuse leg theorem. So here it is. We have that AB, so we have these are congruent, these lengths. These AB is perpendicular to BC. That means this is a right angle. And the same thing with ED is perpendicular to BD, so this whole length. So this is a right angle. So AC is a bisector of BD. Well, let me see again. AC, so here's AC, is a bisector of BD. So that means it cuts it in half. That means these two sides are congruent. It's like the midpoint, but with you're you're cutting the section up. So we're going to write the given. We know that angle B and D are right angles because of this perpendicular definition of perpendicular lines. ABC and triangle EDC are right triangles because it's a definition of a right triangle. It's given that we have AC as the bisector. We already went over this. Let me erase it. Since this is AC is a bisector of this line, means these two sides are congruent. So that's a definition of segment bisector. It's just like the midpoint. Therefore, by our hypotenuse leg congruence theorem, which is here, the triangles are congruent. So it says that if the hypotenuse and leg of a right triangle, so here's your hypotenuse, and the leg, we're just going to use one leg, of a second triangle, then the two triangles are congruent. So that's what we have. We have our hypotenuse, are congruent with both triangles, and so is each of the legs are congruent to each other. And finally, what do we have? All right. It says the entrance to a ranch has a rectangular gate. So that means all these angles here are right angles. You know that AFC is congruent to triangle EFC. All right. What postulate or theorem can you use to conclude that the two triangles are congruent? So we know it's a rectangle, so we know that B and angle D are right angles. And opposite sides are also going to be congruent. The hypotenuse and the leg of each triangle is congruent. So we're given that the triangles are congruent, so we know that these two are congruent and the leg is congruent. So that is your hypotenuse leg congruence theorem. Explain why diagonal of a rectangle forms a pair of congruent triangles. The diagonal of a rectangle will be the hypotenuse of each triangle form because the hypotenuse is congruent to itself. That's kind of like the reflexive property. Because opposite sides of a rectangle are congruent, you conclude that the HL congruence theorem to conclude that the triangles are congruent. And so I'll leave you to read that. The same thing's going to happen when you have squares. You have a diagonal. It's congruent to itself by the reflexive property. These are right angles, and they're opposite each other. So that means the triangles will be congruent. Basically, is what this is saying. All right. Thank you. Have a nice day. Bye-bye.